Hello everyone, my name is Artemy Tomanyans, and today I'm going to give you a quick overview of Python virtual environments as well as Conda environments. We'll be talking about what a Python environment is, why it's a good idea to use it. Then we'll talk about the default virtual environment manager in Python called venv and do a quick demo on it. And later we'll also talk about Conda environments and how to deal with them. So let's start. Basically, a Python environment can be thought of as a glass dome or a bubble within your machine, which includes a Python environment with a certain version, as well as some additional packages also with the specified versions. This bubble or this glass dome is completely separated from the outside machine they're installed on. And that way you can have multiple versions of Python and multiple versions of packages available within the same machine, and not interfering with each other. And this can be very useful when you want to run some different projects on the same machine, or you want to try something out where you're not sure what you're doing and you want to make sure that your simple following of some tutorial does not mess up the whole system that you use for more serious projects, for example. So why it is a good idea to use virtual environments? The first reason is to make your code reproducible. Whenever you start a project and you start developing a certain Python script, it's always a good idea to keep a requirements file at place, listing all of the dependencies of your script, along with the versions that were used to develop the script. That way you can make sure that your code produces the same results on different machines, and you also hedge against changes that might occur to the behavior of functions within packages, so that if you run the same code for a long time, it always produces the same results, or at least consistent results. Also, you can do a lot of experimentation within virtual environments without being afraid of messing up some other project's environment or your machine's environment. And you can also manage the dependencies of your project much easier. So let's jump into a quick demo of venv. Let's assume that your colleague or your co-author shared a directory with you, a folder, which includes a requirements file. And this requirements file can be seen, first of all, by using the list command in the terminal, ls. We can see the contents of this folder. And if we look at this file using the less command, we see that there are 4 packages that will be used for the script that we're developing. And it's important that we use a specified version of NumPy. On the machine that we're using, we do have Python 3 installed. But if we try to look at the packages that we have, we can see that the package manager for Python is not installed on this machine. By the way, the which command that was used earlier just shows you the location of the executable file, the Python executable file that is used to run any kind of Python code. So we don't have package manager installed, but we do have Python installed, and that's actually enough for us to create a new virtual environment. To do so, we use Python 3, then -m, venv, and then the name of the virtual environment that we want to create. Okay, so if we look at the contents of the folder, we can see that the virtual environment folder is now accessible. And also we can look at the location of the Python 3 executable, and we see that it's still in the system because we have not activated the newly created virtual environment. To activate it, we use command source. Then we go into the virtual environment. run bin, and that's where we find activate script. So you can see now that we enter the virtual environment, and if we look at the location of Python 3 executable, we can see that it is now within this stats bank virtual environment folder. So now we can try to see the packages already within this virtual environment, and there are none. You can see that the package manager is now available, but there are no packages in this virtual environment since we have not populated it yet. Let's do just that. Let's install the packages using -r to specify the requirements file and run. As you see, the package manager identified the packages that are specified in the requirements file. It also noticed that NumPy has a specific version that has to be installed. And also all of the dependencies have been installed within this virtual environment. If we look at the contents of the virtual environment, we can see all of these packages that have been installed. So to further reiterate, we can look at this. And what you can see here is that on the same machine, in fact, in the same directory, I have 3 different projects, each of which has its own list of packages. And even if the packages are contained in multiple projects, there can be different versions of the same package available. So you can see that the stats project uses NumPy 1.18, while the ML project uses 121.4, and the same is true for pandas. So in the stats project, it's 1.3.4, and in the ML project, it's 1.0 for some reason. And all of this has been done despite the fact that the package manager for Python is not actually installed on the machine itself. So it was only accessible within these isolated virtual environments. So moving on to Conda environment. Oh yeah, so these are some of the commands that were used to create and to activate the virtual environment. Moving on to the Conda virtual environment, it has a number of advantages compared to the original, to the default Python virtual environment manager. But 2 that I really wanted to highlight are, first of all, the ability to use multiple languages. So you can have a number of R and Python packages available in one isolated environment, and a different set of R and Python packages in a completely different environment, completely isolated environment. And the second thing that I wanted to mention is that Conda environments can have access to the Conda repository of packages. And a lot of corporations love this feature because PyPy, the open source repository of Python packages, has been in the center of multiple scandals about malware being uploaded to the website and then installed by developers who, for example, make a typo in the name of the package and that way get bad code onto their machine. So let's have a quick look at the Conda virtual environments. So we're now looking into a different virtual machine which has Conda installed in it. And if we want to see what kind of environments we have on this machine, we use conda and list command and see that only the base environment is currently available on this machine. In order to create new environments, we would need conda create, then -n to specify the name of the new environment. That would be new env. And then I would specify that we want our base to be available within this virtual environment, and a Python 3 executable with the version 3.7. So what this command did for us was first getting the specs that we specified in our command, and then installing a bunch of dependencies which are needed to actually create this virtual environment with the said R-base configuration, Python configuration, and some other dependencies that are needed for the environment to run smoothly. Now to enter or to activate this new environment, we do Conda activate new N. And compared to the Venv environment, we use Conda list command here to see the installed packages. So this is everything that will be available for us to use in this environment. Let's use Conda repository of packages to install an additional package. The package in question would be PostgreSQL, which is a Python package to interact with the Postgres database. Okay, so what this command did was also finding all the dependencies that are needed, then accessing the Conda forge, the Conda repository of packages, and then installing the package in question on into this virtual environment that we created. You can see that it appeared here. So this is a quick look into the Anaconda virtual environment. So these are some of the commands that we used to create and to activate this virtual environment. One last thing that I also wanted to mention is that in this presentation, I used the terminal interface, which is a more advanced version of managing virtual environments for Python. Meanwhile, there is an easier solution. So for example, both Conda and Venv virtual environments are built into PyCharm projects. So when you create a new project and you go into the settings of your interpreter for this project, you are faced with the options to create a Conda environment, a virtual environment, or using a system interpreter. The same is true for the Anaconda navigator, the IDE, well, the graphical interface for Anaconda. You can change the environment within this graphical interface. You can create new environments. You can specify versions of R and Python interpreters that you need there. And you can also use the requirements file to create a virtual environment with the packages needed for the project already installed there. I will include both of these links in the end of my presentation, as well as the list of various Linux commands that were used. And that's it for me from today. Thank you for your attention.